that implies A row C hold true, that implies row is transitive. So what we see in this portion, we see row is reflexive. In this portion, we see row is symmetric. In this portion, we see row is transitive. So now, as all the three properties are holding true, then we can say that row is an equivalence relation. Understood? Good. Let's have a look into it very clearly for a minute. Then we'll come for the next discussion. Let's see one more example. Okay. Let us change this example a little bit. Capital R is the set of all real numbers, right? Is the set of all real numbers. And rho is a relation defined on R such that A row B, if and only if, our definition is that A row B if 1 plus A into B is greater than 0. This is the rule. This is the property which has to be hold true in order to A row B hold true. That means A comma B belongs to the set row. We are going to see whether this relation is an equivalence relation or not. Let's see. First see, okay, before that, to prove a relation, an equivalence relation, we need to prove whether it is reflexive, symmetric and transitive or not. If any one of these things is not going to be true, then we can straight away say that no, this relation is not an equivalence relation. Okay? Let's see, for any element A belongs to R, what we say? 1 plus A into A is equal to 1 plus A square, which is always greater than 0. Despite A become positive or negative, that doesn't matter. Correct? So that implies that row is reflexive, right? This implies row is reflexive. Let's take AB belongs to row and A comma B belongs to row. What does it imply? That implies 1 plus A into B is greater than 0, because that is according to the definition of the relation. So now if 1 plus A into B greater than 0, that also implies 1 plus B into A is greater than 0. That implies, according to the definition, B comma A belongs to row. So we started with A comma B belongs to row, and we are able to prove that B comma A belongs to row. So that implies row is symmetric. Now, to prove transitive, let's see how we can prove it, okay? Prove it or disprove it. Let's take A comma B comma C belongs to R and A comma B belongs to R, B comma C belongs to R, sorry, not R, belongs to row, belongs to row. So what does it mean? That means 1 plus A into B is greater than 0 and 1 plus B into C is greater than 0. But to prove, we need to show that 1 plus A into C is greater than 0. How we can do it? We do not know. So our intuition says that may not going to hold true. But how we can prove really? So let's take an example of specific values of A, B, C and see whether it is going to be true or not. Okay? Let's take like this. A equal to 1, B equal to half and C equal to minus 1. Then 1 plus A into B is greater than 0. 1 plus half, right? So 1 plus half. So here we see that what is coming? 1 plus A into B is equal to 1 plus half is greater than 0. So AB holds true. Then 1 plus BC is equal to 1 minus half is greater than 0. Right? So BC also hold true. Now 1 plus AC equal to 1 minus 1 is equal to 0, which is not greater than 0. So that means A comma C doesn't belongs to the set row. That means A and C are not related by means of the relation row. Hence the relation row is not transitive. Hence it is not an equivalence relation. Though row is both reflexive and symmetric, but as it is not a transitive relation, hence row is not an equivalence relation. Understood? Thank you. Our last topic in this chapter is inverse of a relation. Okay? Suppose R be a relation defined on any set S, then its inverse is defined as R inverse. That is nothing but B comma A. It contains the order of pair B comma A such that A comma B belongs to R. Very simple, right? So from here, what we can conclude, very clearly is that A comma B belongs to R implies B comma A belongs to R inverse and implied by as well. That is the inverse of the relation. So let me repeat. Let R be a relation we define on a set. Now its inverse, R inverse, is denoted by R power minus 1 and it is denoted by R power minus 1 and it is defined as the order pair B comma A such that A comma B belongs to R. Correct? That is called the inverse of a relation. Now one topic I left actually was a small thing. It's called anti-symmetric relation. Let me describe it now. Let rho be a relation. Rho be a relation on S. Right? Now, if A comma B belongs to rho and B comma A belongs to rho, implies that A equal to B, then we can say it is an anti-symmetric relation. Then rho is anti-symmetric. A comma B belongs to rho and B comma A belongs to rho implies A equal to B. Then we can say rho is an anti-symmetric relation. That is the end of the topic relation. I already sent you the set of study material and question papers on that. In case you have any doubt, okay, please send me email here. It is konar.classes@gmail.com. Okay. The study material and question papers what I sent to you is covering both CBSE board examinations and IIT joint entrance examination in both main and advanced. In case someone is looking into this video over YouTube, please send me an email in this email ID and I will send you the related materials, any query, any questions you have. Thank you very much.